Welcome! In this section, we're going to take a look at the anatomy of a lens and introduce some terminology that's associated with the housing and packaging of a lens. So in optical design, it's a pretty complex process, and there are both considerations for the optical parameters of the system, as well as practical considerations such as the lens housing and control mechanisms. By the end of this section, we should be able to identify the different parameters that may be involved in the packaging and labeling of a lens. An imaging lens is also known as a machine vision lens, objective lens, or just simply as a lens. For simplicity's sake, imaging lenses will often be shortened to lens in this chapter, and for the course in general, it can be assumed that the term lens applies to a whole system of lenses, unless it's specifically specified as an individual or a singlet lens. An objective lens is the lens that gathers light directly from the object you're trying to image and sends it to whatever is looking at it, so either an eye in a microscope, or if it's a machine vision lens, to a computer which will interpret the data. It's usually made up of a group of lenses that work together to produce the desired imaging parameters, and those parameters will be given for the system as a whole. So things like the focal length will be given for the lenses working together, not the individual lenses in the system. There's a wide world of lenses out there, and lens manufacturers will generally provide extensive technical details for their products, but the exact presentation will vary depending on the type of lens as well as the company that is producing the lens. So having an understanding of the basic anatomy of a lens will help navigate these various options and choose a lens that's right for your application. So the image below here shows a camera lens, and we've labeled the various characteristic parts. So as we go through this section, we'll take a look at what these parts do and how they relate to the lens system as a whole. So first off, the focus adjustment ring. Turning this changes the location where the lens focuses best. The distance from the first surface, up here this first surface is the front of the lens, to the object is called the working distance, and that's what the focus adjustment ring will change. The iris, or the aperture adjustment ring, turning this changes the size of the aperture, changing how much light is let into the system. And this changes the F number, which is F/#. In addition to controlling the overall light that can pass through the lens, the F number has many other critical effects on lens performance, which we'll see more later in the course. There's several thumb screws. These are used to temporarily lock the focus or the iris adjustment into place, so that once you've set your parameters you want for imaging, you don't accidentally bump them or change them. The lens information is usually printed on the lens somewhere. This will typically give the focal length, the minimum F number or aperture size that can be achieved, the part number, and the lens manufacturer, which you can use to look up more detailed information on the lens. The working distance range will specify the range over which the lens can focus. This is sometimes referred to as object distance range. So if we were to take a look at this particular lens we have pictured here, it can go from 50 millimeters to an infinite focal distance. This lens is designed to take pictures of objects very far away, up to as close as 50 millimeters. The F number tick marks on the lens barrel, they designate where to turn the aperture adjustment ring to obtain a particular F number. So by adjusting your iris adjustment ring to the appropriate tick mark, you can choose which F number you want to image with. There is the filter thread. This is where machine vision filters can be threaded if the first element does not protrude from the lens barrel. If the first element protrudes past the lens barrel, or if the lens is a wide-angle lens, additional adapters may be necessary. So that's this front edge here where you can thread additional things like polarization sheets and various things a computer may want to filter the information that's coming through the lens. However, if the lens is poking out, that may stop the component from being threaded on due to physical space, in which case you may need an adapter to move that component forward. The camera mount is where the lens is threaded or mounted onto a camera. Typical mounts are C mounts, F mounts, TFL mounts, and S mounts. So there's various types. These have been designed to be compatible across systems. So you may be able to use the same lens on many different camera systems. Then the rear protrusion is the distance past the lens shoulder that the lens protrudes into the camera. So if we were to look here, this is our rear protrusion. All of this highlighted in yellow here is going to be sticking into the camera. You should take care that this part that's sticking into the camera doesn't interfere with any extra filters or electronics inside the camera mount. The first surface is just what it sounds like. It's the first surface that you encounter on the side of the lens where the light is coming in. It can either be the first optical element, or it can be the lens barrel itself if the first lens is inside the lens barrel. The working distance is defined as the distance from the first surface to the object. The last surface is the last surface before the light leaves the lens. And it can either be the last optical lens before the sensor, or it can be the lens mount itself. The lens shoulder is where the lens will contact the camera flange. So when you mount this lens on a camera, this region here will be the part that actually presses up against the camera. And then the overall length is the length the lens will protrude out of the camera when it's mounted. The flange distance is the distance from the mounting shoulder to the image plane. The image plane is where the sensor would go because that's where the image will be formed. This distance is typically standardized between lenses and cameras for various mount types to ensure compatibility. This has been Anatomy of a Lens. Thank you for watching.